A magnet is one of the only objects you can hold in your hand that reaches into empty space and moves matter. No strings, no contact, just force. And we think we understand magnets because we've seen them forever. Fridge magnets, school experiments, maybe a compass. So it feels like this is basic. But if magnets are so basic, why do they still feel like magic? Why can a chunk of metal grab something across empty space? And before we even explain how magnets work, we need to fix one big myth. Magnets don't just pull metal. A magnet won't grab aluminum. It won't grab copper. It won't grab most coins, even though they're all metallic. Magnets mainly interact with a specific class of materials, especially iron, nickel, and cobalt. So magnetism isn't about metal in general. It's about the microscopic structure of certain materials. Now here's another rule that makes magnets feel almost cursed. Every magnet has two poles, north and south. If you break a magnet in half, you don't get a north half and a south half. You get two smaller magnets, each with its own north and south. Break them again. Same result. No matter what you do, you never isolate just one pole. So the real question becomes, where do those poles even come from? And this is where the explanation stops being about magnets and starts being about atoms. Because magnetism doesn't come from the surface of the magnet. It comes from deep inside the material at a scale you can't see. Inside every atom are electrons, and electrons don't just orbit the nucleus. They also have a quantum property called spin. That word spin is misleading because it's not literally a little ball spinning around, but the effect is real. Electron spin makes an electron behave like a tiny magnet. So here's the insane part. Every object around you is full of microscopic magnetism. The reason most things don't act magnetic is because those tiny magnets cancel out. In most materials, the spins point in random directions. It's like billions of tiny arrows pointing everywhere, balancing each other out. So the magnetism is there, it's just scrambled. Which is why most things ignore magnets completely. So what makes iron different? Why does it respond so strongly? In certain materials, especially iron, electrons prefer to align their spins in the same direction. That creates clusters inside the metal where huge numbers of spins match up. These clusters are called magnetic domains. A magnetic domain is basically a neighborhood where the material is already acting like a magnet, even if the whole object isn't yet. If the domains are pointed in random directions, the overall object still doesn't have a strong magnetic field. Everything cancels out again. But if enough of those domains line up in the same direction, now you've got something new. Now the fields combine into one large magnetic field, and it extends out into space. That's what a permanent magnet actually is. It's not magnetic metal. It's organized electron behavior, and it also explains why magnets attract and repel. Opposite poles pull together because their magnetic fields connect and stabilize, but the same poles push away because their fields clash. That invisible wall you feel between two magnets is the fields fighting for space. Now some magnets happen naturally. The most famous is lodestone, a naturally magnetized form of magnetite. Ancient people found rocks that could pull iron long before anyone understood atoms, electrons, or electricity. That eventually led to the compass, and the compass changed navigation, which changed the entire world. But the most extreme magnets aren't ancient. They're modern. Rare earth magnets, especially neodymium magnets, are the ones that feel unreal. Same physics, same domains, same electron alignment, but the material structure locks that alignment in place more strongly. That's why a neodymium magnet the size of a coin can feel like it has superpowers. And it's also why heat can ruin a magnet. Heat makes atoms vibrate. That vibration disrupts the alignment of the domains. So as the material heats up, the domains start to scramble and the magnet weakens. If you heat it high enough, the alignment collapses completely. The magnet basically forgets how to be a magnet. So permanent magnets are all about alignment, order beating chaos. But then humans discovered something even crazier. We learned how to create magnetism on demand. If electricity flows through a wire, it creates a magnetic field around the wire. That's a fundamental rule of physics. Electricity creates magnetism. The field around one straight wire is weak, so instead, you wrap the wire into a coil. Now the magnetic fields stack on top of each other. The same current suddenly becomes a much stronger magnet. And if you put an iron core inside that coil, it becomes even stronger, because the electromagnet forces the iron's domains to align too. So with electromagnets, you're not just using magnetism, you're controlling it. Turn the electricity on, the magnetic field appears. Turn it off, it disappears. This is why electromagnets are basically a cheat code for civilization. Motors work by switching magnetic fields on and off in a controlled pattern, forcing parts to move. Generators do the reverse. Movement changes a magnetic field, and that produces electricity. And speakers work the same way. A speaker has a magnet and a coil. When signals flow through the coil, it creates a changing magnetic field that pushes and pulls the speaker cone. That vibration becomes sound. So when you hear music through a speaker, you're literally hearing a magnetic field in motion. And the wildest use of magnetism might be the MRI. An MRI uses a massive magnetic field to interact with atoms inside your body. It lines up the nuclei of hydrogen atoms, then hits them with radio pulses. When those atoms snap back into alignment, they release signals. The machine reads those signals and builds an image of what's inside you. A magnet so powerful it can map your organs without cutting you open, and magnets are hiding everywhere in your everyday life. Your phone has sensors that can detect Earth's magnetic field like a compass. Wireless chargers use magnetic induction. Laptop lids use magnets to detect when they're closed. Some train systems even use magnetism to levitate. So here's the real takeaway. A magnet isn't special metal. It's a material where trillions of tiny magnetic effects inside atoms stop canceling out and start cooperating. That cooperation creates a magnetic field, a real physical structure that extends into space and can push or pull on certain materials without ever touching them. And once you understand that, magnets stop being mysterious and start being even more impressive. Because we didn't just discover magnetism, we learned how to engineer it with permanent magnets, electromagnets, motors, generators, speakers, and machines like MRI scanners that can literally see inside your body. So the next time you watch a magnet pull something across a table, you're not seeing magic. You're seeing atomic scale physics made visible.